This is Max. It's not a toy, it's an input device for a personal computer, a kind of specialized input device, a vertical market joystick, if you will, for people who play flight simulator games. Indeed, there are many ways to communicate with your computer, to input information into it, from mice to keyboards, from light pens to trackballs. Today, we take a look at a whole range of input devices on this edition of the Computer Chronicles.
The Computer Chronicles is made possible in part by CompuServe, featuring an online reference library, Wall Street reports, at-home shopping, airline reservations, games, and hundreds of other services. CompuServe, helping people get the most from computers. Additional funding is provided by McGraw-Hill, publishers of Byte. Byte's detailed technical articles on new hardware, software, and languages cover developments in computer technology worldwide.
Welcome to the Computer Chronicles. I'm Stuart Chaffee, and this is Gary Kildall. Gary, as you can see here, all kinds of ways to input information into your computer. This is a cordless keyboard. We have light pens, all kinds of funny-looking mice over here, keyboard with 24 function keys. Is any one kind of input device inherently better than the other?
Well, Stuart, as you know, general-purpose computers have had a general-purpose input device, a keyboard, for a long, long time, sort of the standard that everybody can use. But we're seeing more and more specialization in computers now. For example, computers that drive a kiosk where you can go up and buy shoes, for example, and you touch panel to get the item. And so as we see this specialization in computers, we're going to see more and more specialized input devices, and that's going to be real interesting to see what they come up with.
Today we're going to take a look at quite a few special input devices. We'll see a cordless mouse, we'll see a keyboard with a built-in touchpad, we'll take a look at a 3D trackball, and we'll see an incredible device that lets you input information into your computer simply by writing it out in longhand. We begin with a visit to the U.S. Post Office and their favorite input device, the barcode reader.
Most people probably don't think about what happens to a letter once it's been posted, except to hope that it arrives at its destination. Here at the main facility of the Postal Service's San Francisco division, it joins about 8.5 million other letters posted that same day, of all sizes, shapes, and legibility. Faced with about 162 billion envelopes and boxes mailed each year, the Postal Service is eager to expand its automated mail sorting system.
The volume base was getting so large that if we had not done anything to modernize facilities, we would have run out of space in terms of the number of manual cases required to process mail. That's essentially a need not only in terms of volume of mail that we had to process, but also the cost for doing business in terms of that processing environment.
The newest computerized input tools of the system are optical character readers and barcode sorters. Working in tandem, they read the last line and zip code of an address and transform the information into binary barcode data, which is sprayed onto the envelope to expedite sorting. The equipment can process close to 30,000 pieces per hour, about 50 times faster than hand sorting, and at about 1/10 of the cost.
There are discounts available to our major mailers that pre-sort and have readability, comply with readability procedures, and even for those that pre-print a barcode on an envelope is certainly an advantage for the Postal Service. If we get pre-printed barcoded mail to a 9-digit level, that's certainly the most efficient means by which we can utilize our automated equipment.
Joining us in the studio now is Vic Klee with a company called Lightgate, and next to Vic is Dan Mertens with Keytronic. Gary?
Dan, the mouse as we know it, as it was popularized by the Macintosh and so forth, it seems to be a standard kind of an input device nowadays, but you both have redesigned the mouse, and what are the shortcomings?
Well, for one thing, a mouse requires a free area on your desk to operate. And secondly, you're usually performing some sort of operation on the keyboard and then reaching for the mouse. That involves a lot of lost time. So if you can bring that all into one package, it'll make for more efficient input.
Okay, Vic, what are your thoughts?
Well, the mouse takes up a lot of space on the desk. I basically agree with Dan. And in addition, there's no relationship between the mouse and the screen. The mouse has serious maintenance problems, as we've all encountered with our Macintoshes, having to clean the lint out of it on occasion. And in addition, the mouse doesn't have a natural relationship with the screen itself.
Okay, now tell us about Felix.
Well, Felix is, as Stuart characterized it, a mini mouse, actually a miniature optical data tablet, and there's a one-for-one relationship between the motion of Felix and the screen. Felix uses the index, thumb, and forefinger, the same muscle set we use to draw or to write with, rather than the wrist motion and upper arm motion. And so we're also moving a substantially smaller, lighter element.
Show us exactly how you would use Felix.
Sure. To use Felix, you just pick a spot on your desk, typically next to the keyboard, and simply hold Felix in your fingers like you, in a relaxed way, like you would a pencil. And as you can see, there's a one-for-one relationship between my finger motion and the motion of the cursor on the screen, so that I can go anywhere I want and know where I am without actually having to look for a mouse. When I put my hand on Felix, my fingers immediately find the handle. It doesn't matter how big the screen is or how high the resolution. With Felix, we can still point to one pixel or span the whole screen.
Now show us how you can control the windows here with it.
Well, one of the special features of Felix is that there's, if you will, a feel space in Felix. That is, we can feel the corner. When we push all the way to the edge, Felix stops in the corner, stops in along the edge. And so we've associated now with a particular window in any Windows environment, like the Macintosh, those edges and corners of Felix.
So you're saying basically when the cursor hits the corner of the window, you feel it hit the edge of Felix.
Well, what I'm actually saying is that when the Felix hits the corner of Felix and I click, I'm always in the corner of the active window. And if you can see that happening here, I flick and I'm in that corner. If I pick another active window and flick, I'm in the corner of that active window. Okay? So it doesn't require me to accurately position, as I would with a mouse, the cursor with the eye-hand feedback into a position on the screen. Instead, I have a space that I can feel with my hand. Flick and click.
Okay, and how much does Felix cost, Vic?
Felix for the Mac 2 and SE costs $149.
Okay, Dan, I want to get you involved in your version of how to build a better mouse. We're going to go over to the PS2 and take a look at that if we can.
Okay.
Dan, what software do you have up on the IBM here?
Well, we've got a desktop publishing application, and so first what I'm going to show you with the touchpad is a point and select operation. We'll choose a file, and we'll go into this file and double-click just as we would with a mouse to open it up. I've got a misspelling in here, so I'm going to need to select the toolbox for text, and actually what I need to do is select the text and spell it correctly. I want to now go and resize it, so I will come down and select it. I can move it in.
So right now you're really using that touchpad and the pen there really like a mouse.
That's correct. I don't have to reach over, move around on my desk. Now what I'm going to do is be able to issue commands. I want to see how this looks in the page. I didn't have to remember a command. It was right there on my overlay. Go back to the actual size. Let's save this and go look at the touchpad in a spreadsheet application. So we'll close this window. And now I need to close Windows. And you'll see with these handy overlays that come with the touchpad, I don't have to remember the commands because the commands are all written down there for me. Easy to snap in and out, turn the touchpad back on, and let's read a file in Lotus.
So you're beyond a mouse now. I mean, you sort of have function keys now.
That's correct. What I'm going to show in the spreadsheet application here is actually, this is a product that doesn't work with a mouse. I'm going to show fast cursor and command shortcuts. So I read the file. We'll see it on the screen. If I want to view the graph, I don't even have to remember the command for the graph. I just touch the space on the touchpad. I can go back to the spreadsheet. I can switch now to a fast cursor mode and see that I can move around. And in fact, I don't even need to use the stylus. This is a touch-sensitive product, so I can move around this way. So
Dan, how much would it cost to buy a keyboard like that?
$249 is the suggested retail price.
Okay, thank you very much. In just a minute, we'll take a look at a light pen, a 3D trackball, and we'll see a cordless mouse, so stay with us. now is Billy Lewis, president of the Lite Pen Company. Next to Billy is Tim Barry, president of Microspeed, and next to Tim is Charlie Kennedy, here representing Mnemonics.
Billy, you're going to talk about the Lite Pen, show us the Lite Pen. The Lite Pen accessory has been around with the IBM PC since the very early days, but I haven't seen it used a lot. What kind of applications do you use Lite Pens?
Lite Pens are used in some very narrow niche areas. Hospital systems, for example, they use them as in the patient care software program that's actually operated by the doctor and the nurse and the technicians in the hospital. They track the patient throughout the entire system of the hospital using the Lite Pen on the screen. They never touch a keyboard.
What's the advantage there? I mean, why would they use the Lite Pen in that application?
They don't have to teach anyone how to use the keyboard. They don't have to teach them how to use a specific set of programs. It's all on the screen on a menu-driven program, and as fast as they can think, moving their hand around on the screen, they select the target and move on to the next
Let's
product.
take a look at it.
Sure. The Lite Pen is a light-sensing device that will position the cursor wherever I'm pointing. So if I point and push the tip down, I will literally be able to draw or make a menu selection or whatever right on the screen. And it is natural, the hand-eye coordination that you develop in writing or pointing is used in the Lite Pen, so it's the most natural of the input devices in that sense. I'm doing this awkwardly, so you must excuse how it
You're
appears.
upside down and backwards, I
Yeah,
understand.
but the point is that you can go over and you can select, you can do anything you want to do as fast as you select and move the cursor around.
Billy, how does the Lite Pen actually work?
The Lite Pen detects the movement of the electron beam across the screen, which it does 60 times a second. Wherever I'm pointing within that field of view, it's 60 times a second, sending back a pulse indicating this is the presence of the beam. The computer locks up to that and gives coordinate information.
Billy, thanks very much. Tim, let's turn to you, and why a trackball instead of a mouse?
Well, the primary reason that most users give is that the mouse requires a lot more space on their desks than they often have, and the ability to, since the device is stationary, they are able to use it without ever having to look down at their hand and reposition it when it goes off the edge of the desk. Those are the two primary reasons that we hear.
And show us how you'd use the trackball. You've got a spreadsheet up there.
Right. Normally, pointing devices are used for drawing and graphics, but I thought I'd show here how it can improve productivity in a spreadsheet type environment. Here we have the trackball set up to move the cursor on the screen. As I roll the ball toward the top of the screen, you can see the thing moves up, and it moves across as I roll it to the right or back to the left as I roll to the left. Then the third axis, in this case, is defined for page up and page down to allow the cursor to really move very rapidly and give you very rapid control on the spreadsheet.
And how about the buttons? You got 3 buttons on that.
The buttons are defined in this template to be basically the menu selection, so that you can use the balls to then select options. The right button is to cancel, and the left button is for input. We have different templates that we supply for WordPerfect, 123, SuperCalc. All the major programs come with the standard with the device.
And how about the 3-dimensional aspect? I know you can't show that off on a spreadsheet, but how would you use the 3D, the third axis in a trackball?
Typically, what the CAD developers are doing is they're using the third axis as sort of context sensitive. Sometimes it's for zoom in and zoom out. Sometimes it's for rotation about axes. It depends on how their CAD program interface is developed.
And what's it cost to buy a trackball?
$149 retail.
Okay, Charlie, everybody's been knocking mice up until now, and you've got a mouse over there. But yours is cordless.
Right.
Okay, what's the point in having a cordless mouse?
Well, software that uses windowing features generally supports a mouse. Those are packages such as desktop publishing, CAD, presentation graphics, project scheduling. And the cable limits the location where the mouse can be used. So the idea of going cordless is to provide the user a larger work area and still have precise control of the functions that the mouse performs.
But you need a line of sight, as it were, between the two, right?
That is correct. We are transmitting infrared light here, and it is important to maintain a clear path between the mouse and the receiver.
And what's the range of that?
The range in front of the receiver is 4 feet. There's a 90-degree cone of reception, so that at the 4-foot extent, the width of the work area is about 5 feet.
Okay, and other than that, it's a normal mouse, I take it?
Correct. Other than we don't use the roller ball tracking mechanism, which eliminates the need for periodic cleaning and maintenance.
Okay, so if you can just show us how you would use that now, just to prove it really does work.
This is using it with Dr. Halo 3. Here I'll just quickly make a picture of the mouse, give it 3 mouse buttons. Create a spot for our logo. And there's a top view of the mouse.
Okay, and I take it you got, what, a 9-volt battery in there or something?
This is a rechargeable NiCad battery. The back of the receiver is fitted with a jack, as is the front of the mouse, between the two LED emitters. We suggest that overnight you plug it in and recharge it overnight, but it does have a life of 10 hours between recharging.
Gentlemen, thank you very much. Some people think the most intuitive way to communicate with your computer screen is to simply point to the screen or touch it with your finger. Wendy Woods found a touchscreen application at De Anza College in Cupertino, California.
When new students arrive at De Anza College in Cupertino, California this fall, part of the orientation process will take place here, at a computer running an interactive video disc. Students will learn the kind of courses available, how to plan out their program, and just how to get around. You'll notice this student is using the video disc by touching the screen. This touch screen was chosen for the program basically because it's easy to use.
I'm here to take courses just for the fun of learning, things that I'm personally interested in.
The touch screen that Elographics assisted us with essentially was the most critical component to this orientation or interactive program. And the reason for that was that when you consider the number of students that come through this institution and their degree of sophistication regarding computers, we felt it had to be very simple. We didn't want to have to train someone on how to use this orientation, self-paced orientation program. It had to be very simple and they could walk up to it and use it.
De Anza College is pioneering the use of this technology to take the place of timely and repetitive counseling sessions for student orientation. So far, the experiment seems to be working well. So well that De Anza, having just finished a test of the system with several hundred students, will now furnish it for about 1,000 incoming freshmen this fall. In Cupertino, California, for the Computer Chronicles, I'm Wendy Woods.
For various campus services.
Joining us in the studio now is Michael Buffa, president of Nestor Incorporated of Providence, Rhode Island.
Michael, you have a device here that apparently recognizes handwritten characters, is that correct?
That's correct, it does do that.
The obvious question is, why would anybody want to do that rather than just using a keyboard for input?
Well, actually, there are some applications, some classes of people that do not or will not use a keyboard in a given application, such as in a mortgage underwriting application. There are many cases on Wall Street where brokers have been wanting to use some alternative to a keyboard input, and this gives them that alternative.
So you don't see this as an end-user device? Huh?
No, this is not going to be a mass-marketable end-user product. It's really a niche-oriented, specific application-oriented product.
Now, does it recognize anybody's handwriting, or do you have to go through a training process, or what's?
Well, the unique thing about this product, it's based on a neural network AI concept, which closely emulates the way the human brain functions. So anyone can train this system to recognize their unique way of handwriting. And this product works on both the English character, French character set, and even kanji.
How long does it take to train it?
It will take anywhere from about a half hour to an hour, depending on how bad your handwriting is or how different it is.
Could you show? We want to see how this works.
For example, if you're doing an application where you want to enter data on some type of form, say you're in telemarketing or in an application where you want to enter data into the computer through a form like this, the first step is to start the application by touching the pin to the pad, and then you can select a number of functions here. In this case, we want to create a document, so I hit the F1 function. Now, in this case, it just has my memory in the computer, if you will, but you could have any number of users here and call in your specific handwriting style. So I'll just touch the F1 button, which will now read in my memory, if you will. So now the system knows how to recognize my handwriting. So I'll tell the system that I have a memo form here, that I want to edit or create a new document. And the first thing we do is calibrate the paper to the digitizing tablet, and now we can start entering data.
Okay, so you're actually writing on a paper form.
Correct.
So you'd have the paper form when you're done.
Correct.
And as we can see, it's also entering the same information in the computer.
Right. In other words, you can keep the paper copy, but what's happening as you're writing this information onto the paper, it's immediately going into the database of the computer.
Oh, there's a touch-sensitive panel then underneath the paper.
Yes, this is a standard digitizing tablet made by many manufacturers. There's nothing unique about the tablet. It's just digitizing the handwriting, and then the computer is recognizing that.
Could you enter a little more text just to kind of prove to us that this really works?
Sure, certainly.
Mike was too easy.
Is there a certain word you'd like me to write?
No, that's all right.
Okay. Now, what I purposely did here was make a few mistakes. So now what I can easily do is go back and change or correct or edit. So you don't have to worry about how one would, in other words, it's very easy to move throughout the page and make corrections and make changes to the paper.
And I suppose you can make the changes manually here on the side panel also.
What we use this for is if the system is not recognizing a certain character, let's say that it's in the afternoon, your handwriting has changed, you can very quickly go to a training function here and train it on your handwriting once again, and it will become better and better as it recognizes more and more characters. The issue in handwriting is your handwriting will vary from time of day or what mood you're in. So as the system learns more and more about your handwriting, it becomes more and more accurate.
Now, you've got another little box over here,
Yes.
and I want to ask you to explain what that is.
This is a prototype, and it's a very, very interesting concept. We've all heard of the paperless office, and this represents a product that can truly achieve a paperless office, if you will. The concept here is instead of using paper on a digitizing tablet, we actually have an electronic piece of paper overlaying this screen. So one can enter data.
Excuse me, that's the screen really of that Toshiba portable over there.
That's correct.
And you're going to write actually on the portable's screen.
Correct.
Okay.
This was actually built for a brokerage, or this prototype was built for a brokerage firm so that a trader could use something like this to enter information on a trading ticket. So one can go directly to the screen of the computer and enter the data. And in this case, there is no paper, and as one is writing the data, it's going directly into the computer. So it puts the trader online with the computer system in a very natural, normal style.
Could you tell us a little bit more about the AI aspect of this? This is really just character recognition process, isn't it?
Well,
I guess I don't understand why there's an AI component to that.
The AI component here comes from research or development that was done by two Brown professors, a Dr. Leon Cooper and a Dr. Charles Elbaum. They started working about 15 years ago trying to build a computer that would emulate the way the human brain works in terms of recognizing and classifying patterns. And that body of work has now resulted in a form of AI called neural network. And the neural network is the technology that is in the computer that is learning how to recognize these very complex patterns. The same technology can be used for things like learning how a mortgage underwriter underwrites mortgages, or learning how to make decisions on trading situations on the market. And some of those applications are being done today.
Michael, thank you very much. We're out of time.
Okay, thank you.
That's our look at input devices. Hope we'll see you here again next week on the Computer Chronicles.
In the random access file this week, the curtain is about to rise on the new Macintosh laptop. Apple will unveil its first ever portable Mac next week. Analysts who have seen the Mac laptop say it has a great screen, but is heavy, about 17 pounds, and costly, about $6,000. IBM is reportedly about to introduce another laptop, this time a 386 portable with a VGA LCD screen and a 40-megabyte hard drive. The price is expected to be about $3,500. The makers of the original laptop, Tandy, have come full circle and are coming out with a 3-pound portable word processor reminiscent of the Model 100. It will have a full-featured word processor, including spell checker and thesaurus in ROM. It runs off 4 AA batteries, price expected to be around $350. And Grid Systems has introduced a portable CD-ROM drive for use with laptops. Specs are weight of 5 pounds, capacity of 550 megabytes, and a price of about $1,900. Olivetti says it will be the first company to come out with a 486-based PC. Olivetti's president promised the new PC for late October. IBM and Toshiba are joining forces to produce color LCD screens. Plans are to have product out by 1991. The initial plan calls for production of a 10-inch color LCD for use only in IBM and Toshiba machines. Hitachi says it has developed a new ultra-fast computer chip using a subatomic particle called a polariton. Hitachi says the particle has both optical and electronic characteristics and could increase computing speed by a factor of 10,000. Nippon Telegraph and Telephone is taking an unusual approach to computer security. It is encouraging hackers to try to break into its new communications network. NTT says it is offering a prize of 1 million yen to any hacker who can break into the system. The company says if anyone succeeds, they will at least learn something about any weaknesses in the system. The Japanese company Fujitsu has unveiled the world's first online database translator. The system will let you query a Japanese language database online in English and then get output in English within minutes. The system is called ScanFile and is expected to be online in the U.S. sometime in 1990. Data General says it is licensing the New Wave interface from Hewlett-Packard for use in all its office automation products. And IBM says it has just completed a study which shows that 2/3 of classroom teachers are in favor of a dramatic increase in the use of computers in schools. The IBM study contradicts an earlier report from the National Education Computing Conference, which questioned the effectiveness of computers in the classroom. Apple is joining with Gannett to create a new online electronic news service for college newspapers. The news service will feature college-oriented stories. The service is being offered free in return for ad space in the participating college papers. And finally, Carnegie Mellon University says it may be all over for human chess players. CMU's high-tech chess computer just won its 3rd straight regional championship and is now ranked among the top 150 players in the world. And high-tech isn't as good as its older brother Deep Thought, another Carnegie Mellon computer. That's it for this week's Random Access. I'm Kate McGargy.
The Computer Chronicles is made possible in part by McGraw-Hill, publishers of Byte Magazine, and BIX, the Byte Information Exchange. In print and online, Byte and BIX serve computer professionals worldwide with detailed information on new hardware, software, and technologies.
For a transcript of this week's Computer Chronicles, send $4 to PTV Publications, Post Office Box 701, Kent, Ohio 44240. Please indicate program date.